just want to remind all my Gator fans. Yeah, we definitely beat the Gators and Miami Hurricanes too. So again, Golden State would be the state champions. Just want to remind you of all of that in case you didn't see that this weekend. But here we go into some math. We are going to be covering 5.1. It's kind of what we talked about in class today. Classifying triangles on a coordinate plane. I'm just going to go over this real quick. I'm not going to read it to you. These are the two ways to name it. You can name it by angles or by sides. So each triangle will get two names, one by angle, one by sides. These are the names for angles. These are the names by sides. So you would call something like an acute isosceles triangle. So you're going to give it two names. You need to make sure you know both types of names and which one stands. It's going to tell you a lot. We talked about that in class a little bit today. So there's your definitions. You might want to pause the video and go ahead and write that down. I'm going to be moving quickly, so you might have to do that a couple times. I'm not going to do the workout. It's already done for me. We're just going to talk through it. Okay, so first thing, graph these 2 points, and then you're gonna put a third point on there, and based on that third point, you're going to be making a right triangle, which we know would make it 90 degrees. We would make an acute triangle, which would make all the angles less than 90. And then we would do obtuse, which would be one being larger than 90. So I went ahead and kind of marked different points. If you see the black points, okay, the black dots, those are going to be the equilateral, and they would also be isosceles. So if you look at this, or not isosceles, equilateral, and they would be acute. So right here, this triangle that is formed would be equilateral. The reason I know that is because all the distances on this triangle, or on this circle, are going to be equal. So that's going to be equilateral. And then that same thing could happen over here. That would also be an acute. I could do that on this side over here and make that triangle. So that would be acute, and it'd also be equilateral. If I wanted to make the 90, I would go straight down here and make the 90, and it would also be a 90. It would also be a isosceles, so it would be a right isosceles. And the reason I know that is because this is the diameter of this circle, or radius. This is also the radius of this circle, so those two are going to be congruent to each other. So I know that that is a 90 degree and two sides being the same, so it's a right isosceles triangle. I could also do that backwards if I wanted to. I could also do that over here, this way, and again, isosceles, right. And finally, we have our green dot. Pretty much our green dot could be almost anywhere because we're talking about scalene and obtuse. So I go here, and I go here, and then I connect that. But that angle right there is much larger than 90, and none of these sides are going to be the same. I drew a bunch of them. Could be a whole bunch that are obtuse. This green dot, however, would not be correct because that would not be obtuse. There you go. I know it's not 90 because the 90 line would be right here. So that's bigger than 90. Just a little bit, but it is bigger. Alright, so that would be some examples for those. You need to know those vocab words, make sure. Alright. Moving right along. We are going to plot these points. Again, I'm going to do a lot of this quickly. If you want to try this on your own, you can try it on your own. What you're going to do is you're going to plot the points. We talked about using the distance formula to get the lengths of each side. Based on that, I can say if it's scalene, if it's isosceles, or if it's equilateral. and then you can also use a protractor, whatever you need to do to name it by its angles. So here's all the math for that. So there is the distance formula for the two that you need the distance formula for, and their AB you can actually just count because it's a vertical line. So there's the math. If you have any questions on that, make sure you see me in class. You should be able to do that. Remember, minusing a negative becomes a positive, things like that. But that is the full out how you do those problems. Right here, so this is why it is a scaling, because none of the lengths, so this is a length here, this is a length here, this is a length here, and none of those are the same. That is a 5, that is the square root of 5, not the same thing. So that would be why it's scaling. Now I need to figure out if it's why it's a right triangle. So the way that I do that is there's a couple ways. We talked about how you can do a squared plus b squared to make sure it equals c squared if it's going to be a right, which I told you it is. Or you can figure out the slope, which is up 1 over 1, 2. So I get a slope of 1 over 2 is this guy. That's his slope. And this guy goes down 1, 2 over 1. So down 2 over 1. These guys right here are opposite reciprocals, which means they are perpendicular, and that means that they are intersecting at a 90-degree angle. So because they have opposite reciprocal slopes, I know that they are perpendicular, and that is going to make them intersect at a 90-degree angle. All right, the last one we're going to go through. Like I said, hopefully I wasn't going to make the slides too long. So graph this using these points, and then classify if angle A is this, angle B, like I said, you might want to try this on your own and then check your work and see how you're doing. Right here, because all these degrees are less than 90, I can call it a acute. So I know it's by its angles, it's acute. Now I need to check by its sides, so I'm going to have to do again all that distance formula stuff. This one again, I can count. You can count that one. This B to C, which is right here, B to C, they did that work right here. And A to C, they did that work right here. And that's the distance formula. And again, if you look, you have two sides that are the same, so that's why it's called isosceles. We talked about why it's acute. Label it isosceles, call it a triangle, and you are finished. That's it for tonight's homework. Hopefully you got a lot of understanding out of that, and not just understanding that Florida State is the best football team in this state. Again, hope you guys have a good night. See you tomorrow in class.